Welcome everyone. Thanks for joining us today's expert webinar. My name is Aaron Samuel from SpringPeople. SpringPeople is India's biggest corporate technology training company. As a part of our expert webinar series, today we are very glad to have Mr. Vishal Chahal, Chief Architect for Cognitive Solutions, IBM. If you have any questions during the presentation, please type in the question in the question box. And at the end of the session, Mr. Vishal will answer all your questions. Now, without any further ado, over to Mr. Vishal.
Thanks, Aaron. Give me a second while I share my screen. Before I start off, let me just confirm if everyone can see my screen.
Yeah, Vishal, it's visible now.
Okay.
Great.
I think there's some chat happening. Let me just. Good afternoon, everyone. This is Vishal. I'm going to cover today part one of a series of webinars that we plan to do. The part one covers the current and future trends, the current state of the art, and the future trends that we see in near term that will be developing in the market. Second part, obviously, is a follow-on that SpringPeople will put up information about. But starting with the first part, let's just start with the base that we're going to cover today, which is around artificial intelligence and machine learning. So let me just come to why I'm trying to cover both of them together. Is because we are in a world which is not going to be taken over anytime soon by machines. We are dependent on machines today, and more importantly, machines are stupid, and they need some way for us to be able to make them smart. AI and machine learning is one of those ways to make them smart. Are they really something which is significant, or are they just buzzwords? Well, AI has been a buzzword since long. So, it started appearing in Google Trends around 2014. But if we look right now, some of the trends that are occurring are around machine learning and deep learning. But all of these are related together. How are they related together? Because they're part of something called a hype cycle for data science. If you look at this chart, it may be a little confusing initially, but look at the x-axis there, the time part, which actually says that it initially, a technology, a hype cycle starts with innovation, trigger, then it goes to inflated expectation, then it goes through disillusionment, then enlightenment, and then the productivity starts. At this point in time, we are into a peak of inflated expectations out of deep learning and machine learning. It'll certainly start entering a part of disillusionment at some point of time, but then enlightenment will certainly occur, and it'll go into a productivity cycle. And we are seeing some trends there already. To put everything into perspective, the overall universe today is artificial intelligence from a technical point of view. Machine learning is an enabler for artificial intelligence, and deep learning is a type of machine learning. So that's how the perspective is. Artificial intelligence, if you look at the timeline shown below, has been around for a long time now. So it has been there since 1950s. Just that the enablers for artificial intelligence have become very, very achievable and active in the last 10 years or so. So more importantly, the deep learning part is the most important part of artificial intelligence. That's the enabler today. How is it? Just to explain a little bit of what machine learning is all about. Machine learning is actually something like you take some data and you put it through something called a training cycle, right? You train on the data and you learn something based on an algorithm, right? Once you've learned something, you would take the learning part, use that into a prediction cycle, and you will get some new data. You will use your learning on that new data, and you will do some prediction. The learning is encapsulated today in the form of something called a model. machine learning model. Now, all of this essentially is supposed to be done in such a way that you don't have to explicitly program this. So the idea being that the algorithm can learn from the data that it is learning through the training cycle, and the model should encapsulate all kind of logic that it has to apply on the data to be able to do prediction around it. But what are the different kind of approaches that exist today? Well, there are three different approaches. There is obviously the supervised learning approach, which is where you learn with a labeled data set. So you are given a data, let's say in a CSV file where you have the columns named, and you're labeling the data by saying, well, this is the age column, this is the gender column, this is the salary column, this is whether you will accept the offer column, etc. Right, that kind of thing. Further on, when you move, you have unsupervised learning, wherein you are trying to discover patterns from unlabeled data, wherein I wouldn't call it a fully unlabeled data kind of an approach. You still need some kind of labeling of the data, but a typical example can be things like you give an image to a machine learning algorithm. It'll take the bitmap of the image. It'll train its model on that image to be able to identify objects in that image, and that can be in the form of the object that it sees. That can be in the form of segmentation it can do, etc. on that, or that can be in the form of multiple correlations that exist within the objects in an image. All of that can be done using your unsupervised learning today. But the most important part is you do not have to do too much of labeling of the data, right? This is a totally purely data-driven approach, the unsupervised learning part. The supervised was task-driven and mostly labeled data-driven kind of an approach. The third approach that's caught on now is reinforced learning part of it. Well, you do not have the data available for all the different scenarios. Is there a way we can actually, instead of trying and labeling data every time, we find a way that we learn on the fly and we give feedback based on the learning that's been done, whether it's been good, bad, ugly, and then we reward based on that. And the algorithm based on the reward mechanism keeps on improvising itself to do a better learning. So you do not have to do labeling of the data per se, but you do have to give a lot of feedback when the algorithm is learning. This is more popular towards robotics and the autonomic cars and autonomic different kind of machines that have to be trained. You cannot train them for all kind of different situations that they have to go through. So reinforced learning is one of those approaches with some of the examples that I mentioned. Now, what is deep learning here then? Well, deep learning is obviously a part of machine learning, but it is very, very effective at learning the patterns. Right? And it utilizes different learning algorithms to really go about it in such a way that it can derive meaning out of the data by using different kind of views or different kind of layers on top of the data. More and more information you provide, better it learns on top of the data. So in this case specifically, you do not actually have to prepare any kind of features in the data. Now, features in the data are similar to what I was, alluding to earlier. Things like the gender, the salary column, etc., that you may put in a data, or actually marking instances in data when there have been spikes, or actually deriving data from an existing data. Those are all feature engineering part. Deep learning doesn't need feature engineering. It will engineer the features based on the learning it has of the patterns in the data. Now, but what is artificial intelligence then? So we have just gone through what is machine learning, what is deep learning. Artificial intelligence, if we have to put it in a quadrant kind of a system, is composed of things like you would like to put it across thought and behavior and human and rational quadrant. So if you go from top left, so we want a system which thinks like human, right? we probably want a system which can act like humans. So that's the quadrant which is combination of behavior and human, right? We want systems that can think rationally, and we want systems that can act rationally. When you put it all together, if you have all of these being satisfied, you actually are looking at an artificial intelligence system. Now, the question may be, because the topic today is about the current and future trends. Currently, we are mostly at the top left quadrant, wherein we have built systems that can think like human or imitate the thinking of humans. We have a whole lot of advances being done in robotics, wherein system can act like humans physically, as well as a little bit on the side of behavioral aspects of humanoids in the form of robots. But as far as the systems that think rationally and systems that act rationally part is there, that doesn't exist today. It's not a mature technology right now. Um, the current state, if I have to say, of AI is nothing but it's mostly around inferential statistics. Let me qualify that statement in the next slide. Why do I say so? The kind of areas of AI and the dependence that exists between them from a technical layout is something like you have a very basic paradigm called search. All of us who actually use IT today, either as a consumer, designer, programmer, etc., do a whole lot of use of search, right? So the paradigm for AI also is going to be search, because you have humongous amount of data there. So you want to search, start from somewhere, and search is a good way to start. And then you want to do interaction on that search based on natural language processing. So you have NLP for short, right? How do you want to do this? So obviously, machine learning is going to be part of it. How would you actually be processing and responding to that? Vision would be one of the ways of doing that. You would need to apply logic when you're doing all of this, right? You will need to do planning when you're trying to do this. You can bring it all together using robotics. But more importantly, whenever you're doing this, when you're doing it for scenario A in a given situation, you should be able to do it for scenario B in a different given situation. And that can be achieved using knowledge representation of all this being together. And then once you have done that, you would actually arrive at something called expert systems. Currently, I think we are not at a stage wherein we have a good way of doing knowledge representation, good way of doing machine-driven logic or expert system. So that's why currently it is inferential statistics. Where we want to be is inferential reasoning. And again, just to say, because AI is weak in certain areas of knowledge representation, transferring the knowledge representation across scenarios from scenario A to scenario B, where the conditions and constraints are different, and actually putting them through an expert system is lacking. And where we want to go is obviously the inferential reasoning kind of systems. If I had to give a perspective of putting it all together, current trend is actually going towards modern AI. Presently, we are transitioning from traditional to the modern AI. So what is traditional AI? Obviously is about feature engineering. So you actually had to label data, you had to put the data into certain structures, then only the algorithms could understand them. Humans were involved into annotation of data. Data pipeline was actually controlled by humans, right? Or even the processing part of the data. And it was obviously sequential. And hold on to this word sequential, because I in the future trends, I'll discuss that, how we're changing this. In the modern AI era where we are, and in the near future where we'll be, is going to be based on hierarchical layers of abstraction of models. And when I say model, it can be either machine learning or a deep learning model. And we can today deal with unlabeled data types, and we can employ the machine learning, deep learning models to achieve multiple decisions simultaneously. So we are into the modern AI era. Now, I kept the slide pretty much empty on the left side, and I put a whole lot of stuff on the right side, simply by showing you the only approach that you get to hear from the current trends perspective is AI or deep learning is all about neural nets now, right? and you have different approaches of doing that. People have done different ways of doing, but if I have to explain it in simple way, you had a way of doing artificial neural networks, right? And there have been approaches called CNN, RNN, LSTM, GAN, and reinforced learning, and all kind of different approaches. But all of them are all about dealing with how are you going to get the data, process the data, and make sense out of the data, right? But the biggest problem that has started to occur now is that you may not have the data for all kind of different scenarios. So the first premise that you want to get started with neural networks is you need to have humongous amount of data to be able to train that. That one is getting defeated. Now, one of the instances to be able to say that is around, let's say, I'm not sure how many of the participants of the webinar would have heard it, but there are papers that have been released which showcase that if you had an image and you could change only a few of the bits of the image, and the neural net may not actually identify that image correctly. So you could essentially, if this was possible, you can essentially put a payload inside an image which may be harmful, right? And a neural net will still identify that as an image, and you will still accept that as an image on your machine, and that may do an harm to your machine, right? This kind of things led to a whole lot of newer approaches that are still part of the current trends, things like generative adversarial networks, what we call as GAN for the, in a short form, which were actually trying to see if there is a way neural network itself can identify data and if there is a change in the pattern in the data, neural net can also identify the change and be able to produce based on that change. Now, this is not the way the theories are written wherever you may read on Google or some other stuff. But to explain it in a simple way, as of today, most of the use cases that exist around deep learning is around images or sound, etc. But pretty soon, you would, or there are research teams that work on actually applying these to different other files. So you could have a file that comes as an attachment to you, which may have a pattern in itself. Or is there a way a neural net can today identify any changes that occur in a file, or reproduces changes that occur in a file that have been different from the way it should have been earlier, or be able to actually use neural net to be apply cryptography on top of that in such a way that you cannot modify the file without actually, without destroying the whole content itself. Those are the kind of approaches that are being looked through right now. But I've kept the left pretty much empty, just because those approaches are being looked at from a research point of view. They do not come out in the open or in the product set right now that you all as developers, as programmers can actually use. They will be mostly white papers. So that's the analogy I've kept on the left side. Anything that's white paper and it's not code is the left side, the research area. The right side is what you all get to use today. But what is the kind of level of artificial intelligence that we are working on right now? The current trend is around something. If you look at this pyramid, the current trend is around narrow AI or the weak AI. So what that defines itself is narrow AI is more or less like ability for a machine to reproduce a specific behavior of a human. So, for example, a specific behavior like being able to identify the text or the spoken word in a speech, right? Or being able to identify an object, or being able to identify and segment an object, that kind of thing, right? In near term, we are actually moving towards a strong AI kind of a thing. Not really general AI, but kind of a strong AI, wherein we're trying to see if we can reproduce human intelligence, not fully, but at least some kind of a self-awareness kind of thing. This is where robotics has advanced a little further, and some amount of work has started to happen, but there are very less examples of that. But actually, at some point of time, the level of intelligence is supposed to be a strong AI kind of a thing, where its behavior and its intelligence is more than humans, all the humans combined, and all the different kind of models that we can deploy, all of them combined, and still you will have an AI system which is more intelligent than. As I was saying, around strong AI, we are actually reaching a point wherein today AI is being used to augment a human's ability to think and design things. So AI is actually being used actively to design newer parts. So for example, for CAD/CAM software, when they combine with AI today, they can design a totally new part without much of a human input. So humans can just give the skeletons, and you may want to search through YouTube on some of those videos to look through. But the idea being that humans will simply give some kind of a outline of a structure, and the AI can design pieces of the structure with totally different designs or design suggestions. And if you like them, you can freeze them, and you can check for the engineering constraints and rules, whether they are satisfied, and you can print them. Those things are already happening. There are examples out there on YouTube which you can look through, wherein aircraft parts or newer pieces that have to be designed on some specific engineering products are being done today. So strong AI is starting to occur. General AI is far off. Super, obviously, way off. What you're seeing on the screen is what you get to feel every day, wherein well, you have cars that are autonomous, you have mobile phones that embed model today which allow you to actually identify objects, you have games that are being played by AI system, and humans are being defeated there. So those are the current trends that you get to see every day. So again, around the same thing, AI and ML is currently doing all of this segmentation, identifying objects, identifying background, identifying foreground, identifying all kind of correlation that exists when they see things. Most of this is visual, by the way, because 80% of the processing that even humans do today from an input point of view is based on visual. It is getting traction into, obviously, serious industry scenarios. The right image is obviously around cancer cells, and it can identify cancerous growth in cells, and it has been looked at from a serious adoption point of view. In healthcare, you have the most number of startups in healthcare really looking at AI in a serious and differentiated way. One of the examples that you can relate to is the disaster management kind of a scenario on the left side that you see, where you have drones deployed with AI models on the edge, and they can actually process the image on the edge and actually identify where the damage is. Now, what I'm showing is part of the trend itself, wherein AI will, in the near future, as in when I say near future, 1 to 5 years kind of thing, AI is actually getting used on the edge rather than actually being used on heavy duty GPU machines. So it can be on the edge right now. You have a whole lot of concept about transfer learning. The images that you see, for example, the painting one, where you have a female and a painting, and the painting style is being transferred to the photo of a female. That's a prime example of transfer learning. The current trend is that you would take transfer learning and apply it. Now, the trend is catching on in different aspects of machine learning that will enable AI. So as of now, when you actually use any of the packages and frameworks, most times you would see examples and code available for visual aspect of it. But it is being used heavily in speech to text now. I think there was some paper published recently by Amazon where they said it is the use of transfer learning which has enabled them to do drastic improvements in their speech to text. Similarly, it is being used heavily for natural language processing now. Transfer learning is actually starting to help there. A lot of papers have been written in last 1.5 years around how transfer learning can help in NLP. Transfer learning is also starting to occur for customized scenarios for industries, wherein based on how industry processes happen, you would have artificial neural nets built in such a way that they can do transfer learning from one scenario in an industry to a different scenario in the same industry. That's starting to occur. So you will pretty soon see libraries being published where you have, along with the tool set and frameworks, you will have transfer learning models available for different scenarios. The kind of technology landscape that we are in today is based on obviously neural nets. I'll go from top uh, um, clockwise. So you have obviously autonomics, which forms part of autonomous vehicles, autonomous equipment and robots, etc. You have virtual agents. That's really the current trend now. It's not actually chatbot. It's chatbot plus search plus machine learning put together. So virtual agents are really the in thing right now. Obviously, machine learning is the backbone. Image recognition, we have really seen the examples right now. People are starting to look at different ways of doing knowledge representation. GraphDB is the most popular one right now, but that's not the most optimal way of doing a knowledge representation, because graph databases are known to um, um, be slow beyond a certain million number of nodes. I believe there are good amount of work being done on distributed graph databases in such a way that you can have knowledge representation done. But imagine a neural net model being converted into a graph, and how will that behave? So those are the kind of uh, near term AI work that is happening. NLP, as I said, is in there. Machine reasoning is coming in, and I'll give you an example at a later point of time on how machine reasoning is happening. Chatbot, deep learning, speech recognition, computer vision, all of these are part of the technology component that we know today for AI. If I look at a high level, how this competitive landscape is spread across from a current trends point of view, you have players who actually do infrastructure, and obviously IBM and Microsoft, Google, Amazon, all of them play there. More importantly, Alibaba is actually a very big player there, and we don't really take cognizance of that. If you look at above that from left to right, you have a whole lot of API-based kind of frameworks available, which allow you to use machine learning or deep learning models in an API fashion and be able to code application and solution on top of that. It's more of a plug and play kind of a thing. And most of this work is IBM, Microsoft, Google, Amazon. But beyond that, when you move towards the right side, you have very custom engagement packages being built, and that's where the agent that I was referring to earlier start to occur. So you have proprietary solutions there from either it's the technology ones, or it's the consulting companies, or very niche players who are actually doing very proprietary solutions around them. And then there are open frameworks that are available or being used primarily to build those custom solutions. So it's not as if when we use custom, the earlier avatar of using your own custom products and libraries, they do not exist anymore in the AI and deep learning world. It's the adoption of these open source packages that is driving these custom engagements. Assistants and chatbots are obviously the in thing. You may think that chatbots have been popular for last 2 years, 3 years, and what's the big deal today? The big deal today is that they have taken a form in such a way that they are available today on the edge. So Alexas and all those are part of those current trend of assistants actually getting a form factor. And obviously there are a whole lot of business applications that are being infused with AI that are out there that most of us as developers and programmers do not get to see every day. But when we start doing enterprise solutions, you really have to build or infuse AI into them. I'm going to give an example of that in one of the later slides. Moving on, the AI landscape today is filled with a whole lot of startups around different horizontal areas, right? Well, obviously maximum in either health tech or fintech area. Well, a lot of them are starting to work on education, travel, hospitality, etc. You name it and you have it. Even on software development side, there are a few startups that are actually coming up that are saying that If you let's say given a piece of code, it can generate the rest of the code for you based on learning from certain libraries and that kind of thing. AI is being used heavily for AR, VR experience from a next gen perspective, text analytics, HR, you name it, and AR is there across, AI is there across all different horizontal and verticals that you can think of. More importantly, there are so many different startups there that each piecemeal solution you can think of, there is a startup trying to handle that. So that's the kind of current trend in the market, in the sense, instead of going for a strong AI or a generic AI, the market today, or the way the technology is being developed, is that you have a startup trying to handle one specific functionality, and that way you have many startups. The chart is just trying to show you that you take an area and you'll have 10 or 15 different startups at that specific area trying to handle that. Now, how things are going to pan out in near future is going to be based on what is your product offering and what is your business strategy. Now, today everything is revolving around product offering in the form of frameworks, libraries, APIs, packages, etc. Right? But if you do not have a business strategy around that to really say how will we enable the developer community to develop solutions on top of that, how will we enable the businesses to adopt them, then all of them do not come together. So this chart is actually showing you different vendors that exist. This is not to show you who's good or who's bad, or who's doing good or who is doing bad, but this is mostly to show you where everybody exists on a product versus business strategy. And this is one of the most important things to really follow from a current trend to how future is going to be. The current trend is around product offering. Everybody just focusing on that. But future trend is going to be around business strategies. Who's going to pull through, who has a good product offering, and who's going to pull through with a very good business strategy around that. And the top right quadrant is the one that actually showcases the top players there. Moving on, the current trend is adoption of AI in enterprises. That's the current trend. How? Let me give you an example. Now, AI is today getting embedded into different kind of business workflows that are out there. For enterprises, business workflows and IT, processing, handling, servicing, all of those business workflow is the bread and butter. What's happening is AI is starting to make changes, improvisations, optimizations in those business workflows. So here's an example that's being shown here. That let's take a mortgage approval workflow or a customer care workflow, just to simplify it, assuming that you had to take a loan. So there are business workflows that exist today that are owned by different businesses. IT companies are actually servicing those business workflows. There are optimizations that need to be done in that, so that the customer is taken care of. Instead of you going through 20 different steps, you can do, if you can get an approval for a loan in, let's say, 5 steps, that is the desired state today. Businesses are starting to see the value of AI trying to improvise all of those steps here. So for example, let's say all the way, if you had to take, let's say, a loan approval today, the way things happen is that you have to do, and I'm going to talk purely technical rather than the business part of the process, is when you submit your document, you have to do optical character recognition, OCR for short. On top of that, you have to classify the document. You have to classify the information that exists in the document. You want to discover certain facets and attributes around entities in those documents. Then you want to understand that using a natural language understanding kind of a model, and put it all together as a flow and feed it to a neural net, a CNN. Now, when you have to do that today, if you do not have a way of infusing it at different steps, then all these processes today, let's say a loan approval process in a normal scenario takes a few days today, right? As soon as you start infusing AI into that, if you look at the OCR model part of it, today AI models can do OCR in an automated fashion, embedded inside a mobile phone, end to end. without you actually needing to put it on a website, you're submitting document. All of those are not needed today, right? You can have AI running at the edge as part of the business process itself. Somebody coming to you with a mobile phone which has a model running that can do OCR, that can do classification of your document to say whether it's a passport or a driving license, discover the information out of it, and apply a neural net on top of that. Now, at different stages, different ways, AI is getting embedded. Now, most of the places where we are seeing current trend is that wherever there is complex processes that exist today, there is a mix of or augmented mix of human as well as an AI system doing it together. And typical example is robotic process automation, where as of today, you see a robotic process automation is being done wholly through a code piece. But pretty soon in the near future, we're seeing that AI will start actually writing RPA kind of flows in such a way that the humans will need to just verify the information that's getting collected so that decision is taken right. And a decision engine based on AI will run it, and you can actually see whether the optimization has occurred on top of that, and you just approve. That's the kind of approach that's being seen in the industry right now. This is one of the examples. There are many examples like that, but probably loan approval is something that we all may have gone through once in our lifetime. And then we see how those steps do take time, and AI is actually taken seriously to improvise in a very simple way the whole workflow. This is one of those examples of the current trend today. I'll just skip this slide because I don't want to spend time on this. I'll just go directly into the future trends part of it. Now, when I go into the future trends, what we're seeing is that there's a layered. So if you have questions, please keep on typing them. Probably I'll have to address them later as soon as I'm finished with my set of slides. But now I'm entering the part of where I see the trend, the future, near future, and a little far off future kind of a trends that we see in the market. Now, what's happening today is that you have layered models or layered architecture being deployed for AI. What that means is you have APIs, which is what we call as the base AI models, right? All of those frameworks that I showed on the previous slide. One of the previous slide was around different kind of APIs and architecture that are available. On top of that, the a layer is being developed wherein a very specific industry or domain model is being deployed. And what is being allowed today is that based on a combination of a base API or a framework-based model infused with a domain AI model, the end user is allowed to customize those models in such a way that AI becomes more user-friendly, right? So you have a very layered approach being employed to deploy the AI models, so that one model can use the output of the other, one model can use the transfer learning of the other, and actually be customized by the end user. That's the kind of trend that's catching on. So that's the layered strategies that is getting adopted to build the AI model. So trend number one. The second is to use a hybrid approach of deep learning and machine learning. What's being seen is that you can use deep learning models to actually get the output in such a way that they can provide you features, and you can take them in combination with some of the classical ways we used to do feature engineering with the existing data, and combine them together to actually do a hybrid approach of developing the model. Why this is being done is obviously to improvise on training, so that you don't actually have. So, and let me give an example of that. Let's say you today using a deep learning model, you can identify a face, right? So that's facial recognition. Today you can identify text on any image, right? Now, if you were to actually build a model which identifies a government ID card, now journal approach today is that you would take a lot of images of government ID cards and feed them to a neural net model and try and train them. But when you start taking hybrid approach, what happens is that you can use existing models to come out with deep learning features out of an image. So for example, if you show it a government ID card, let's say Aadhaar card, it can identify a logo there. It can identify the face there. It can recognize that face. It can identify text there and actually do extraction of the text and the information within. And those are what we will call a deep learning feature that have been identified from an image using existing model. You can train with a simple SVM kind of an algorithm on top of that to really be able to say wherever there are these features available from a deep learning model, they are probably a part of a government identity card. Now, what this allows us to do, it allows to do faster training with existing models, existing data, with higher accuracy and incremental learning. So it's not only transfer learning, it's more of a transfer-based incremental learning that's occurring. So that's the second trend or second approach that's pretty popular today, or going to gain currency in the near future. One of the other approaches around inferential way of doing AI. Let me just give it with an example that I show on the screen here. What if we were to ask a question saying, in May 1898, Portugal celebrated the 400th anniversary of the explorers' arrival in India? So that's a question we fire at a system. And we give it evidence saying in May, Gary arrived in India after he celebrated his anniversary in Portugal. So the current way, if you use machine learning and statistical way of doing the solutions, is that we will match celebrated with celebrated because it's a keyword kind of a match, right? We will match in May to in May kind of thing from a time perspective. We'll match anniversary to anniversary, India to India, and then you will actually, in this kind of a case, get the answer that it's Gary. But if you were to actually go into something called a newer trend around AI inferential reasoning, you put the same question and you give it evidence like on 27th May 1498, Vasco da Gama landed in Kapad Beach. And then you were to actually take it through different layers of the hybrid approach that I was talking about. You take it through a layered way of doing temporal, statistical, geospatial reasoning. And in a temporal way, you would be able to match 27th May to the 400th anniversary because of the 1498 to 1898 difference. So that 400, it will match because obviously that's the way temporal models work. It will be able to match landed to arrival because there's a way to do a paraphrasing of language text. It will be able to match India to Kapad Beach, obviously, because that's geospatial kind of a reasoning. It will know that Kapad Beach is part of a India geospatial hierarchy, right? And it will, for explorer, it will give the answer Vasco da Gama. So this is an example of inferential kind of reasoning trend that's happening. There are not too many products out there that actually show how this has to be done, but the most popular approach, I'm going to show a slide that actually has implemented that, is based on something called evidence and knowledge graph based reasoning, right? So you would see an evidence, and then you will use a deep learning model to gain features of that evidence, map that to a knowledge graph and say, is it actually telling me something? Is there a way I can come out with some kind of reasoning on top of that? So the example here is, if this image was fed to a deep learning model, it can actually identify that this is an insect. It has carapace and it has wings. And if you were to actually match it to a knowledge graph and do reasoning on top of knowledge graph, you will be able to find that that's an arthropod. So inferential reasoning is a near future trend, and it's happening in the form of the IBM debater. These are some of the cuttings of newspaper headlines that occur for it, but you can see videos of that wherein it has been debating with humans on different topics. There is a way wherein you can actually give it content for a topic, and it will identify the pros and cons and for-point and against point on a topic, and it will be able to debate based on the inferential kind of reasoning on top of that. So that's one of the trends. Moving on, you will actually have custom hardware coming in. So custom hardware is going to be part of the way we do things. Today, for AI, the most important aspect when we are training as well as running the AI solutions or deep learning models is around GPUs. There is a new look being given to how the hardware is going to process the deep learning models and AI solutions. And one of the ways we've been looking at it is something called neuromorphic chips, right? So IBM has designed a chip called True North, which has been in production for some time. There are different projects that are going around that, so that it's been designed to process the information in a neural net kind of a way. So you have 1 million neurons there, synapses there, and in a real time, it can process the way neural networks are supposed to be processed rather than actually processing them on GPUs, right? GPUs is a way to process them today because of the matrix multiplication and summation that has to happen. So, I mean, I don't have time right now to actually explain that, but just to say that in the base of neural net training today is based on convolutions, and convolutions happen because of a matrix multiplication of filters and the image and other stuff. And that, because it is memory intensive, happens on GPU because graphic cards were actually designed for that. But that's probably not going to be the way in near future now. You will actually have custom hardware. All the different vendors apart from IBM also are looking at designing their custom hardware to do AI processing. You may want to read up how Tesla actually has designed a totally custom hardware to run locally on the car to be able to do autonomous driving. Quantum computing, that's the most important change that's going to happen in future. All of the machine learning and deep learning that we do today is based on a sequential computing. Remember, I had mentioned that in one of the previous slides that hold on to that word. So this word sequential computing is part of the programming paradigm today. The way computers work today, the classical computers as we call them, is that you give it an instruction, and instruction is done sequentially. Quantum computing is changing that. There is already a quantum experience that's available from IBM on cloud. You can actually search for IBM quantum experience. Everybody can just log in and sign up for it for free, log in and actually try and see how they can program a quantum computer. But quantum computer and using machine learning on top of that is going to be the trend, because it allows you to not only make the training faster, but inferences faster. But look at the way we do deep learning today in a totally different paradigm. Today's session may not have good enough time for me to explain how quantum computers will be using machine learning, but look at it this way: they will allow you to do for example, the gradient descent kind of a thing that happens today in deep learning in a very parallel fashion. At one point of time, you can do gradient descent of all the features in one go. It's not possible in the classical computers today. So quantum is going to be a very, very important trend in future from AI point of view. Just going a little further, between 2018-19, very near term, the kind of importance that's going to come in AI is around data. You will have a whole lot of frameworks and products and pipelines being built so that you can actually have very good way of dealing with data to be able to do AI. And within IBM, we say that as IA will enable AI, right? The information architecture will enable AI. So data is going to be in near term, actually having a very important aspect will be having the right information architecture. That's the trend that's going to happen or happening right now, that everybody is moving to. So AI is popular, but actually having the right infrastructure and the architecture for it is the most important thing happening right now. If I actually, because time, I believe the time is a little less, if I have to go a little longer term kind of trends that is going to happen, some of the important ones are, for example, in the second point, breakthroughs in how systems are trained and algorithms are developed. Digital twins is going to be very, very important aspect in future. You will actually have a way of doing AR and VR driven digital twin for machines, for humans, for any kind of scenario. Today, for example, the way we look at machines is that you have machine producing data consumed using IoT, and you do predictive on top of that. In future, instead of doing that, you will have a digital twin of a machine and be able to use AI on top of that to be able to say how is it behaving, how it's going to behave, and if you marry that concept with quantum, you would actually be able to do similar simulation scenarios on digital twin in real time. The trend that's going to be pretty popular is going to be edge AI. A lot of vendors are coming out with their own different edge devices that allow you to run deep learning models on the edge without actually requiring huge number of GPUs, etc., to process and infer. So edge AI is popular, right? It's just catching up, but in longer term, most of the AI stuff is going to be either distributed or an edge. I've talked about the hardware design for AI, the neuromorphic chip that I showed you, the ethics of AI. That's the current currency that's holding off. IBM actually has come out with a product called IBM OpenScale, wherein being able to look at the bias in the data, de-bias the data, and actually being able to audit how the system has come out with a decision based on a deep learning or a machine learning model is going to be the most powerful thing. Because this is going to be AI is getting adopted as part of business processes in enterprises. Auditability is very, very important. It is catching up, and it's going to be most important thing. There are instances of AI-enabled cyber attacks that are there, but I would encourage the audience today to read up on quantum. And there is a way using quantum cryptography which is going to play a major role to really take care of those cyber attacks. So time doesn't permit, but I would say quantum cryptography is the way to go, and AI will have a big role to play in there. AI itself will become creative. The example that I was giving about the design part of it, that is happening to an extent in research, but that will become mainstream. So 3D printing, when actually combined with a creative or a design-driven AI, will become a trend in future, wherein when you have to design a new thing, you would actually consult an AI system to suggest different designs. You would choose the design and send them for 3D printing in a simpler way. One of the most important trends that's going to catch up in education and HR is going to be the coach and team player kind of a concept. So AI will act as a coach as well as a team player for you. You would have an AI as part of your team. Especially in HR systems, we've been working on certain solutions where we're thinking you can actually have an AI system guide you how you can actually improvise on your skills, how you can go to the next level in your career, how you can improve certain set of skills combined with the current role that you have. So AI will start becoming more like a coach to you, which you can consult for different contents and different aspects. So these are some of the longer term AI trends I believe are gonna occur. When I say longer, it's not like 20 years, it's like 5 years kind of a window. So that's just about it that I have for today. We're gonna obviously have a next session for it, but probably this may be a good time to take some questions. Let me stop the share right now. And let's see if I can take some questions. Okay, there are too many. I don't know which one to start with straight away, but let's say. Would you like to explore how? Okay, this is for you guys. I believe you have to give a poll. Okay, there's a question, AI model uses deep learning, machine learning, or it is a separate entity on its own? No, AI is not a separate entity. It uses deep learning and machine learning, but it is much more than just these. AI is a combination of deep learning, machine learning, knowledge representation, logic, etc. Right? But it uses them. So that's question one. How IoT devices use AI and ML is the question. Well, obviously, all the streaming data that comes in, you may want to predict certain feature based on certain trends in the data. You may want to predict something, and AI ML is a good way of doing that. How will AI data driven become EI emotion driven? Mentoring topic. Interesting. That's really interesting question. AI can become EI kind of a thing if it actually has EI related data around people. Today, when we, for different companies, if you look at the kind of HR data that we have today, it's mostly around a very static way of looking at you. It's all about how your skills are, how they're going to be improvising in future. But I think if we start collecting emotion data and demographic, match that to demographic data that's there, AI will start becoming very relevant to the mentoring part of it. Do you suggest new beginner to jump directly to AI or first learn ML? I would suggest you would need to learn machine learning first and then AI. What do you expect technical project manager to learn in AI? It'll be important for technical project manager to learn how different life cycles have to be done to achieve an AI solution or a deep learning kind of a model. It's just the knowledge of those layers or the deployment, train to deployment life cycle that needs to be learned. And that should be good for a technical project manager to know. Could you please show us a demo of quantum? I think we need a separate session to do quantum AI. That will be very interesting to show. We have a few examples to show you how quantum computers help in ML, but that has to be a different session. There's a question, do AI systems act with prejudice? Depends on the data we feed. Yes, certainly. It's called bias, and based on the data that we give it, AI systems can be prejudiced or biased, yes. How easy for software tester to build career in AI? I won't say it's easy, but it's not difficult either. So if you are a software tester, but you've been good at a few of the programming languages, especially Python, then I think you're half ready already. You just need to know the right set of tools and frameworks to use, and you can get onto the path of becoming an AI developer. I won't actually answer some of the questions that have just come in now. I think I'm probably done with the session right now. There are too many open-ended kind of questions that probably may not be easy to answer within the given time frame. Thanks all for your time. We're going to have a part 2 of this session wherein I'm going to apply AI onto a robo in a live session and show you how robots can behave differently and intelligently based on AI. Thank you. Thanks again. Thanks for your time.
Thanks, Vishal. And great. Thanks, everyone, for coming in. And we appreciate you being here. We will share the recordings tomorrow. And please visit springpeople.com for upcoming tech webinar. The next webinar will be on 25th of April. And as Vishal said, it's going to be a live session. And thanks again. See you next time.